questions from sound. So this whole exercise is related to questions of sound. In the first one, a sound wave travel through air at a series of compression. Compression means the region where the particles are close to each other we call compression, and rarefaction means the particles are away. Which row correctly shows the air pressure? So in a compression the pressure is high, whereas rarefaction the pressure is low. So the option B is the right answer. Then in question 2, a sound wave has a certain amplitude and frequency. A second sound wave is quieter. Quieter means it is having low amplitude and lower pitch. So pitch refers to frequency, where the term pitch is same as the number of vibration per second, or refers to frequency, whereas amplitude refers to the loudness, or loudness refers to amplitude. Because it is quieter, so it means amplitude is decreased, and it is having a lower pitch, so frequency is also decreased. So what happened to amplitude? That is decreased, and the frequency is also decreased. That's why the new wave will have smaller amplitude as well as smaller frequency. In the third question, a fire alarm is not enough, like it's not loud enough, and pitch is too low. So it's not loud and its pitch is too low. An engineer adjusted the alarm so it produced a louder note. So it produced a louder sound or a louder note and a high pitch. So louder means amplitude should increase, and higher pitch means frequency should also increase. So larger amplitude and greater frequency. That's why D is the right answer. So pitch always refers to frequency and amplitude refers to the loudness. A dolphin is there, has a range of audible frequency from 150 hertz to 150 kilohertz. Whereas which range of a frequency can be heard by human and as well as a dolphin? So the range of frequency which a normal human being can detect, that is from 20 hertz, starting from 20 hertz to 20 kilohertz, or 20,000 hertz we can also say. So when we check the 20 cannot, a human ear can detect 20, but a dolphin cannot detect 20, so it cannot be A. When we check the second option as well, so 20 cannot be detected by the dolphin. When we check the last option C, 20,000 hertz, 20,000 hertz to 150 kilo. 20,000 hertz can be detected by both dolphin and human. Like this is a range for the dolphin and this is a human. So dolphin can detect 20,000 because that is within 150 to 150 kilohertz, and human can also detect 20 kilo, but 150 kilohertz can only be detected by the dolphin. The human beings cannot detect that. 150, both dolphin, because that's the starting range of a dolphin, and that is there in the human audible range of a human. And 20 kilohertz is the maximum which human being can record, and that is also in a audible range of a frequency heard by the dolphin. That's why D is the right answer. Then a girl notices that she shouts into a cave and hear an echo. What is the meaning of echo? Echo refers to reflection of the sound. Whenever wave or the sound bounce back, we call that as a reflection. So this is not diffraction, dispersion, it is actually reflection. In question 6, a sound wave travels from a medium in one state to another. This causes the speed of a sound to change approximately from 300. So 300 is the speed of sound in gases to 3000. So 3000 is speed of sound in solid, because If you remember the range, the speed range in gas, it travel around 300. In liquid is about 1500, and in solid the speed of the sound is 5000. So it means that the sound wave is actually traveling from gas to solid. That's why A is the right answer. Is it clear? Question 6. Any doubt till this point? In question 7, a sheet of ice float on the water. A source of a sound is there which is positioned at the edge. So this is the source of the sound. In the question, which microphone detect the sound first? Like which will take a shortest time? So here the sound is traveling in air. So it will, the speed of sound in air is about 330. Here it is traveling through water. So when it is traveling through water, the speed of sound is 1500. Here it is traveling through water as well. So that is 1500. But in ice, which is a solid, so it is traveling through solid, the speed of a sound is 5000. So because speed of sound is 5000, so B, it will take the shortest time as the sound is traveling faster in solid. The next one, a sounds are produced by vibrating object. A certain object vibrate but a person cannot hear. So what could be a reason why a sound is produced but a person is not able to hear or detect the sound? So which statement could explain why nothing is heard? Amplitude of the sound, if amplitude is too loud, then the person should hear. The frequency of the vibration might be too high, like it might not be in an audible range, it might be more than 20 kilohertz or 20,000 hertz. So that's why the person might not be able to detect. It cannot be see, sound waves are not transverse, sound waves are longitudinal. And speed of the sound wave is too high. If speed of sound wave is too high, then the person should detect that sound, the sound should reach a person. So there can be two reasons why a person might not able to hear the sound. Number one, frequency might be more than 20,000 or less than 20. That could be one about frequency. And the second thing is a loudness. Like sound is it's too low that the person is not able to detect that sound. In question 9, in an experiment to find the speed of the sound, in an experiment to measure the speed of the sound, a student uses a stopwatch the time for the sound wave to travel from X to Y. And she does 6 times. So 6 times this experiment is repeated. Which value the time should be calculated or should be used to calculate the speed of sound? So which value we should use? We can take the mean here. So how to work out the mean? We'll add them and divide it by, because there are 6 numbers. So 0.5 plus 0.7 plus 0.6 plus 0.4 plus 0.9 plus 0.5, and then this whole is divided by 6. So when you sum and divide it by 6, it will be about 0.6 second. So to take an average, sum the values and divide it by the total. The next question, a swimmer is sitting on a rock at a seashore looking at the passing waves, he noticed 5 complete wavelengths in 20 seconds. So basically 5 wavelengths or 5 waves are there. What is the frequency? Frequency means number of waves every second. So to get the frequency, it is the number of waves divided by the total time interval. So there are 5 complete waves and the total time it took is 20 seconds. So 5 divided by 20 is 1 by 4 and 1 by 4 is equals to 0.25. So A will be the right answer because the frequency, or you can use a ratio that number of waves and the time. So there were 5 waves in 20 seconds. Frequency means number of vibration in 1 second. So in 1 second, X waves will be there. You cross multiply, you will get the frequency. That will give you the same result as 0.25 hertz. A girl notices that when she shouts into a cave, then echo is produced. So echo is always refers to reflection. When the sound waves bounce back, reflected back, we call that as echo. So C is the right option. In question 12, in a test, a car horn found to be too loud. So too loud means greater amplitude and its pitch is too high. What information does this give about the amplitude and the frequency? So amplitude refers to loudness and frequency refers to the pitch. So pitch is high and it is louder. So what happened to amplitude? Amplitude will be too large. And what happened to frequency? Frequency will be too high or too large. So whenever we say that sound is loud, it means it is having a higher amplitude. When we say sound is having a high pitch, it means it is having more vibration per second or it is having a higher frequency. When a student wishes to measure the speed of a sound in air, she planned to measure a time between the sound and hearing an echo. So if she's hearing an echo from the cliff, like example, if this is a cliff and this is a source. So what happened? The sound will travel, it will strike the surface and then sound will bounce back. So formula for speed is equals to, because whenever there's a reflection or echo, the sound travel and return back. So the distance will be 2d and time will be t. That's time for echo. So the formula which we should use, or the distance which we use here, it will be 2d. So either B will be answer, B can be an answer or D can be an answer. But what about the type of sound? Continuous sound, like if we are producing a continuous sound, the sound is traveling and then sound returned back. So if we are producing a continuous sound, we are not able to identify that which sound, as we are continuously producing a sound, so sound is striking a surface and coming back to us. So we are not able to recognize or identify whether this sound is due to reflection or due to the source. That's why we should not produce a continuous sound. So we should produce a short and a sharp sound. When we produce a sharp sound, that will go strike the surface and then it will bounce back. So once we hear that sound back again, we can identify that this is due to the reflection or echo. That is why D is the right option. Is it clear? Question 13. The diagram shows wave shape of two different sound. In practical, sound waves are not transverse. This is just a representation of the waveform. So the scales are same for each. So when we compare the height, both have the same height. It means both have the same amplitude. So sound 1 and sound 2 have the same amplitude. But when we compare the pitch means the number of vibration per second or frequency. So this is having more vibration. So sound 1 is having a high pitch and sound 2 is having a low pitch. So how does sound 2 compare with sound 1? So sound 2 is having a higher pitch compared to sound 1 is having a higher pitch compared to sound 2. Or opposite, we can say sound 2 is having a lower pitch than sound 1. That's why D is a right answer. Both have the same amplitude, that's why both have the same loudness. So when we compare the loudness, it will be same, but the number of vibration per second are different, so the pitch is different. Which two rows state the properties of a sound wave? Sound can travel through they cannot travel, sound cannot travel through vacuum, so it can travel through water, like a medium. Sound required a medium to travel, and sound waves are not transverse, sound waves are longitudinal. Transverse waves, all the electromagnetic waves are transverse in nature, like radio waves, gamma rays, x-rays, these all are transverse. Another question, a man holding a starting pistol. So there's a man who's holding a starting pistol and standing 640 meter away from a spectator. So there's a spectator, a person is there, and the distance between them is 640 meter. The spectator hears the sound after 2 seconds. Like when a person when fires a shell, so two things will happen: light and sound, both will produce. But a person recorded the sound after 2 seconds of this lightning, the flash. So we need the speed. So how we'll get the speed? Because in this example there is no reflection. So if there is no reflection, the formula for speed is equals to distance divided by time. So the distance travel is 640 and the time it took is equals to 2 seconds. So 640 divided by 2. So speed is equals to 320 meter per second. So option B will be the right answer. Is it clear? Because there is no reflection, that's why we just use this distance between the source and observer. If there was a reflection, like if the sound bounced off from the surface, then it should be 2D. In question 17, a boy blows a whistle of frequency 10,000 hertz. The boyfriend cannot hear. So this is in an audible range, because the normal human hearing, the range is from 20 hertz to 20,000 hertz. So 10,000 can be heard. But why his friend is not able to hear this sound? If amplitude is too large, then he should hear. Frequency is too high, that frequency is not too high, not too low, because that is in the audible range. So why a person is not able to hear? Because the amplitude might be too small. As the sound travels from one place to another, its amplitude decreases, and eventually a person, like maybe standing at this position, so he will not be able to detect any sound as the amplitude is not high. So when the amplitude of the sound is too small, or either the frequency is beyond or below the audible range, or above or below the audible range, then we are not able to hear that sound. In question 18, a lighted candle is placed in front of a loudspeaker. A candle flame vibrates. So which type of sound waves are there? Because what happened, why this candle flame will vibrate? As there are particles in air, when the cone of the loudspeaker vibrate, it causes the particle to vibrate as well. So due to the vibration of the air around the candle, the flame will also vibrate. So which direction the particle are moving? The particle always move parallel, so they will move right and left. And what kind of wave is sound waves? So sound waves are longitudinal. That's why C is the right answer. Is it clear? Any doubt till this point? So in a longitudinal wave, the particle vibrate parallel, whereas transverse wave, the particle vibrate perpendicular. Then a student claps once she's standing 100 meters from a large wall. Like example, this is a wall and a student is standing 100 meters from the wall. That's the distance between the wall and the student. The speed of the sound is 330. How long after clapping does the students hear an echo? Echo means reflection. So whenever there is a reflection, basically when she clap, the sound produced will travel towards the wall and then it will hit the wall and it will bounce back. So whenever there is a reflection, the formula speed is 2d divided by t. So speed is how much? Speed is 330. 2 multiplied by distance we don't know. Distance we know. Basically we need the time here. So distance is 100 meter and how much time she took, that we don't know. So we cross multiply. So t, this is 330. 2 multiplied by 100, that's 200 divided by t. And then we cross multiply. So t is equals to 200 divided by 330. So when we divide the two numbers, it will come out as 0.61 second. Because there is a reflection, that's why we use the formula 2D. If there was no reflection, then we don't have to use this 2D. Is it clear, this question? In question 20, the diagram represents two sound waves. Again, as you can see, because these sound waves in practical, the sound waves are longitudinal, means the particle vibrate parallel and it is having compression and rarefaction. But because it is difficult to represent the amplitude and frequency by using this manner, so how we represent these sound waves, we represent in terms of transverse waveform. So in the question, which statement describes the wave? When we check the height, amplitude, that is same for both. If amplitude is same for both, what does it mean? They have the same loudness. But number of vibration, the first one, there's only one vibration. So sound wave 2 is having more vibration, so it is having a high frequency, or we can say high pitch. Whereas the first one is having a low frequency or low pitch. So which statement describe the waves? The waves have a different loudness, so that is wrong. They have the same loudness. The wave have different loudness, again that is wrong. The wave have the same loudness and same pitch. That is all. Same loudness is correct, but they don't have the same pitch. The wave have the same loudness, but they have different pitch or different number of vibration per second. That's why D is the right answer. In question 21, different waves are given. 4 waves are there. So the diagram represents the wave produced by 4 sources. The scale of a diagram is same for all, which is having the highest frequency or highest pitch. Frequency or a pitch refers to number of vibration per second. So which is having the most vibration per second? This one is having the highest vibration per second or highest pitch. That's why D is the right answer. Because the number of waves for this one, it is 1.5 waves. For this one, 1, 2 and around like 2 quarter, you can say 2.5 about. And this one is 1, 2, 3, 4 and 4.5, or 4 quarter is there basically, because it does not complete the half. For this one, 1, 2, 3, 4, 5 and 6 are there. So this is having the highest number of waves. That's why it will have the highest pitch. So pitch is refers to number of vibration every second. Question 22. A girl stand at a distance from a large building. She claps her hand, and a short time later she hears an echo. Why is an echo produced? Or why there is an echo? Why she's able to hear her sound back again? Because of reflection. Echo is always produced due to reflection. Sound waves, the sound travel by a motion, vibration. Which property of a wave causes echoes? So why the echo is produced? It is due to reflection. So again, C will be the right answer. Then question 24. A student listen to a machine that makes sounds of different frequency. He can only hear one sound. So because if he's having a normal human like range to detect the sound, which is from 20 hertz to 20,000 hertz, or we can also say 20 kilohertz. So 2 will be too low. Again, 10 will be too low because 20 can be heard. 2000, yeah, 2000 is there, and this is 30,000. 30 kilo means 30,000. So 30,000 cannot, we cannot detect because more than 20,000, and 10 hertz cannot be detected because it is less than 20, and 2 cannot be detected because it is less than 20. So the sound which a student can record or detect, that is equals to 2000 hertz or 2 kilohertz. So you have to memorize this audible range. You can write 20 hertz to 20 kilohertz or 20 hertz to 20,000 hertz. So both ways you can mention that. Then a structure question related to a topic sound. A student, two students are there, they want to measure the speed of sound. A student are provided with a starting pistol. So first a student is there, he's having a starting pistol, and another student is there, he's having the stopwatch. And they will measure the distance between them by using this measuring tape or throttle wheel. So when a person fires a shell, two things will happen. It will produce light and it will produce sound. So there will be light, and the second thing, there will be sound. Two things produced at the same time. So when a person at position B, like example, if we mention, like label these positions, this is A and this one is position B. So when a person at position B, when he see the flash, the light, the moment he see the flash, he will start the timer. And the moment he hears the bang, as the sound reaches, he will stop the timer. So the time interval will be there. The distance is already measured, so we can use the formula speed is distance over time. We'll get the speed of a sound in air. And for experimental accuracy, they should switch the position and repeat the experiment for better result. So whenever we want to measure speed of sound in air, we can use this technique. You have to write the procedure, but I explained in detail that how it can be done, and even in the explanation part, the whole experiment we discuss in detail. Another question, a device at the bottom of a sea emits a sound of frequency 200. So a sound is having a frequency of 200. The speed of a sound in a sea water is 1500. What is a wavelength? The frequency and wavelength and speed are, the frequency, wavelength, speed are related by a formula. V is equals to F lambda. That's a wave equation where v is the speed, and this is valid for all types of wave: light waves, sound waves, radio waves. So v is the speed, which is 1500. Frequency we don't wavelength we know, frequency we don't know. Sorry, frequency we know, wavelength we don't know. Frequency is 200 here, and the wavelength is lambda. So 1500 divided by 200 is equals to lambda. So this will cancel out. So 15 divided by 2, that's equal to 7.5 meter. So 7.5 meter is a wavelength of this wave which is produced. The sound wave passes from seawater into air. So in seawater, the sound travels faster. In water, the sound travels slower. So here the speed is fast and speed decreases. State what happened to, if any, to the frequency. Frequency never changes, nothing will happen. But what happened to speed? Because for light it is opposite. Light travels faster in air as compared to in a medium such as water or water or solid. But for sound travel faster in dense medium. That's why in seawater it was traveling faster, but when it travel into air, the speed of the sound will decrease. Because sound required a medium. In air, the particles are not tightly packed together or not very close to each other as compared to water, in which the particles are close. The radio waves, ultrasound, and visible light all are waves. What is meant by ultrasound and suggests a value for minimum possible frequency. So what is meant by ultrasound? What is the meaning of ultrasound? Refers to, as we know, like the frequency of a sound, the audible range is from 20 hertz to 20,000 hertz. That is the audible range. So sound which is having a frequency more than 20,000, that is called ultrasound. So ultrasound, our ear is not able to detect this ultrasound because it is having a higher frequency. So what is meant by ultrasound? So sound which is having a frequency more than 20,000 hertz. Then state which of these waves are electromagnetic. Electromagnetic means they can travel through vacuum. They do not require a medium. So when we check radio waves, ultrasound and visible. So which are electromagnetic waves? We have radio waves and visible. So radio and visible both are electromagnetic. It does not require a medium. And which is longitudinal? So sound waves are the longitudinal waves. Is it clear, this question 3 part A, 1 and 2? Any doubt till this point? In question 4, ultrasound passes through both human flesh and the bone. So ultrasound can pass. Figures 5.1 shows an ultrasound sending an ultrasound wave into a human flesh. The ultrasound wave travel the flash at point X and then through to the thickness, and at Y some of the ultrasound reflected, means ultrasound travel from X to Y and then it returned back. So whenever it bounced back, it means there is a reflection or echo. The total time for ultrasound to travel from X to Y and then back to X, that is 9 exponent minus 6. The speed of the ultrasound in the bone is for 4100. What is the thickness? So we have the formula, speed is distance over time, but this time the distance will be 2d. And what about d here? D is actually the thickness or t. So we can say speed is 2t divided by, otherwise you will be confuse. So I will use the word equation. If I write T for thickness and T for time, so you will be confused. So you can write speed is equal to 2 multiplied by distance divided by time. So speed is how much? That is 4100. 2 multiplied by distance. What is the distance? The thickness we don't know. And the time it took, that is 9 into 10 to the power minus 6. So this 9 into 10 to the power minus 6 is divided. Other side it will be multiplied. So it will be 4100 multiplied by 9 into 10 to the power minus 6 is equals to 2 into t. So 2 is multiplied, other side will divide. So 4100 multiplied by 9 into 10 to the power minus 6 divided by 2. So that will give you the thickness of the bone through which this ultrasound is passing. And that will come out as 0.018. When you substitute the values, so the thickness will be 0.018 meters. Is it clear, this question? So whenever there's a reflection, you should use 2D. If there is no reflection, any kind of wave, it's not only for sound. Even if it was a light wave, then we will also use 2D. But if there is no reflection, then it is directly D. A loudspeaker produces a sound wave of constant frequency. What is meant by frequency? Definition of frequency: it is number of waves in 1 second. So how many waves are there in 1 second? That is refers to frequency. The sound wave travel in air towards the barrier. The small gap is there. Figure 7.1 represent the compression toward the barrier. What is meant by compression? The compression means a region where the particles are closer, a region of high pressure. That is known as compression. Then the width of a gap is smaller. So whenever we have a smaller gap, how we draw the wavefront? It will be maximum diffraction. And one thing you have to keep in mind, like example, if this distance is 2 centimeter in the figure, so your approximate distance should also be 2 centimeter. Some students, they used to draw in this manner. That is wrong. Why? Because if you change the wave distance between the two wavefront, it means you change the wavelength. So when you draw the distance, when it is a small gap, narrow gap, maximum diffraction, but the distance should be same. Like if this distance is 2 centimeter, then this distance should also be 2 centimeters. So using a compass, you should draw this wavefront. The barrier is adjusted so that the gap become wider. Describe what happened to the pattern of a compression. What happened, or so if the gap is wider, then what we have a small diffraction because the gap size is smaller than the width. So these are some questions related to sound.